Pythagorean triplets will save you time. If you're thinking, what the heck is a Pythagorean triplets? It's our a squared plus b squared equals c squared. The most common we need to know are 3, 4, 5, or 5, 12, 13 is also very common. So if you don't know that, I'm going to go through this as if you don't. So how do I get to this point 3, 4? I go 3 to the right and up 4. So this is a distance of 3, this is a distance of 4, and I can go a squared plus b squared equals c squared to figure out this. So a squared plus b squared equals c squared. 3 squared is 9, 4 squared is 16, and we can see 25 is equal to c squared. Normally we would say plus or minus, but because we're talking about this distance, it's always going to be positive. So that's how I achieve 5. Also, even quicker, we can see the radius of the circle is 5. I should have been able just to get 5 from looking at the entire graph. Let's come over here and do the same thing. So if you know your triplets, we know we go 12 to the right, and we go 5 up, so that's our coordinates. Horizontally, 12 to the right, positive 5, 5 up. We can see that in this particular problem, we have a radius of 13. So we need to have this memorized, right? That's one of those double angle formulas we need to have memorized. So I'm going to write it down right now. The sine of 2 is equal to 2 sine of the angle, and I'm just going to write it like this, 2 sine of the angle and cosine of the angle. Okay, so that's what I have at this point. And now we're going to go ahead. Let me move this to the side. This is my computer. Now, what I probably should have done, sorry, my computer's been on too much this afternoon and it is starting to overheat. I need to keep this exact same symbols going. All right, so what does this mean? Well, let's come up here and let's just identify what is the sine of this angle and what is the cosine. Remember, sine, cosine, tangent, those trig functions are just a way to describe 2 of the 3 sides of our right triangle. Specifically, sine, we know, is going to be opposite over hypotenuse, so positive 4/5 here. And we have a cosine that's going to be adjacent over hypotenuse with 3/5. So I come back over here, I have 2 times the sine. The sine, we can see up above, is 4/5 times the cosine, which is 3/5. If I multiply across, I can see I have 25 on the bottom, and 8 times 3 is 24. We have an answer of C. Let's move this up and let's look at number 717. Okay, so to continue on, I see that we have one of the sum and difference trigonometric identities. So I'm going to come over here, and these are things we have to memorize. It was cosine of A plus B. So I'm going to write this down right now. We have the cosine of A plus B is equal to the cosine of A cosine B subtract sine A and sine B. All right, let's come back to our table here. And so we do have to keep it in the same order. So my A is first and beta is second. All right, I'm going to come back up here. We see this and we're going to say the sine is equal to opposite over hypotenuse and the cosine is equal to adjacent over hypotenuse. And literally then I'm just plugging things in. So I'm making my marks here. And I'm going to start with, on the left-hand side, cosine is 3/5. So 3/5, and now I need a cosine over here, which is 12 over 13. And then I'm going to come back here to the sine. The sine is 4/5. Don't rush so much and make a small mistake and inputting in the wrong value. And then we have the sine is 5 over 13. Well, the nice thing is I can see already that I'm going to have a common denominator, and that's really nice. And we can see the common denominator is 65. So we've got that down. Now 3 times 12 is 36, and 4 times 5 is 20. If we subtract, we get 16 over 65, and the correct answer is A. Let's look now at 118. We have a possibility of using any one of these 3 double angle formulas for cosine. Really our choice in what we choose to use. I kind of want to do the least amount of work. So I'm going to write down the cosine of 2 equals 2 cosine squared minus 1. Okay, so then I'm going to come up here and figure out what is the cosine here. The cosine is 12 over 13. So I come back. Now I need to take and write this down twice because we are squaring it. Now I know that 13 times 13 is 169. Now 12 times 12 times 12 is 144. And then I need to double 144, and you can see I get 288. So I have 288 over 169, but then I have to subtract 1. Well, 1 is the same as 169 over 169. So now I want to subtract 188, subtract 169, and I can have my correct answer. All right, my phone is dead. I'm going to have to come off and do elementary math here. All right, so I cannot take 9 away from 18. 9 away from 8. 9 away from 18 is 9. This 8 went down to a 7. I take 6 away from 7 to get 1, and 1. I should have 119 over 169, and we can see that answer is C. Now let's look at number 19, the last one for the picture up above. All right, jumping down to this last one, hopefully you recognize this as one of those sum or difference. So I'm going to jump over here, and I see subtraction in between. So I'm looking at this one right here. Let me highlight it for us. So I'm going to take sine, cosine, subtract cosine, sine. Sine, cosine, subtract cosine, sine. Let me come back here. We have sine, cosine, subtract cosine, sine. All right. Okay, so I need to go back up to the top left, and let's figure out my sine was 4/5, my cosine was 3/5. Again, my sine was 4/5, and my cosine was 3/5. Now at pi over 2, we have a cosine of 0, and we have a sine of 1. 0 times anything is 0, and then 1 times 3/5 is 3/5. We should have a negative 3/5, or option B.